I'm going to do is kind of do a little summary, step by step, and walk through the atomic structure of an atom, looking at its electron configuration, looking at characteristics, where it is on the periodic table, so we can kind of get a feel for all of the things that were talked about in the previous class. So let's start with potassium. Potassium is a very interesting element, is a dietary supplement, and it is good for your body. So potassium spelled Potassium. Do not get it confused with the chemical symbol P, which is for phosphorus, but potassium's chemical symbol is K. If we had to list the atomic number, we will find that on the periodic table and we'll see that that was 19. If we had to list the mass number for the most abundant atom of potassium, then we would look at the average atomic mass and see that it's closest to 39, which means that the mass number for the most abundant isotope of potassium will be 39. We also see that the average atomic mass is 39.1 AMUs. The number of protons, 19, the same as the atomic number. The number of neutrons, 20 for the particular isotope that we're talking about, 39. And the number of electrons in the ground state is going to be equal to the atomic number, so that's 19. All right, potassium is a alkali metal. It is in the first group on the periodic table, the first column, which makes it a metal, and more specifically makes it an alkali metal. Now, let's look at if we were to make the Bohr model for potassium. The Bohr model for potassium will give us a nucleus that had protons equal to 19, neutrons equal to 20. And around that nucleus, we're going to have a total of 19 electrons. We're going to have 1, 2, 3, 4. Why? Because potassium is on the fourth principal energy level. It's the fourth row down on the periodic table, which means that if we were to draw all of the electrons associated, we have 2 in the first energy level, we have 8 in the second energy level, we have 8 in the third energy level, and we have 1 in the fourth energy level, which will give us a total of 19 electrons. This will be the Bohr model for a potassium atom in the ground state, specifically potassium 39. All right, now if we wanted to look at the electron configuration for potassium in the ground state, then the electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now we've shown this electron configuration a different way in terms of energy, and we have the 1s, 2s, the 2p, the 3s, the 3p, and the 4s. So we have 1s, 2s, 2p, 3s, 3p, 4s. And to fill this in, remember we use the arrows. The arrows need to have different spins on them. And we fill this with 19 electrons. This will be the electrons as a function of their energy and the particular orbitals that they're in. Now, if you were to be asked how many valence electrons, then potassium has only one. And it's in the highest energy level, which is the 4s energy level, fourth principal energy level, and s orbital. So, to show the Lewis dot structure, or Lewis dot diagram, for a potassium atom in its ground state, the Lewis dot structure has one electron above potassium. And this would be a walkthrough of all of the basics of the atom. We looked at the nucleus, we looked at the atomic number, the mass number, the average atomic mass as reported by the periodic table, the number of protons, neutrons, electrons. We looked at the Bohr model, and then we looked at the electron configuration via energy and written out in a traditional manner, the number of valence electrons, and the Lewis dot diagram.